welcome all. Thank you for joining this afternoon or evening, wherever, depending where you are. This is the second session in our Pay-as-you-go Quick Start. Out of 4 weeks, we are almost halfway through, where we'll take you through the most important aspects of taking an Apigee Pay-as-you-go organization into production and what would be required of you to know, to look at. We'll discuss best practices and we're able to answer any questions. So today we have, let me see if the co-presenting works. Today we have two experts on the call. That is Harish from London and Nigel also from London, not technically living in London. I think a little bit north of that, but UK to keep it general. And they are taking you to a really deep dive session today. So we take it on from where we left it last week. I hope you have watched the recording if you were not able to attend. And we'll take it one step further to dive a little bit deeper into the aspects or the technical things you need to take into consideration. And yeah, these two amazing experts have been with Apigee for quite some years, so I'm sure you are in good hands with them. Yeah, so the agenda looks, oh, I clicked to one too many, I think. The agenda looks quite big, so there's a lot of different topics that fall into this deep dive, from the networking to more advanced proxy building. I know we started about that last week, but we will dive a bit deeper into it. But also things like security, which are important for every Apigee deployment. Security and APIs go hand in hand, and Apigee can offer a lot around that. But also analytics and publishing around the developer. There's 2 hours planned. Nigel, Harish, I'm not sure if you plan to fill the 2 hours. Probably looking at the agenda, it will be kind of a full session. So I will repeat a few of the messages from last week around the Pay-as-you-go Quick Start, just to remind everybody what we're doing here. These are virtual sessions. We will record them. We go from foundation to deep dive. And as it happens today, we are at the deep dive. But there's also other sessions planned later around governance, around how to land this within your organization, more around best practices. I would say more than non-technical best practices. And also things like how to support your business with Apigee and APIs. What can we tell you about other use cases and reference cases from our other customers? So I think all in all, this is a full package that will learn you a lot, from how the product works to how to land this in your organization. And that's the idea here, to really help you get from where you are with Apigee Pay-as-you-go into where you probably want to be, and that is to have things running and having value for your organization. So in the program, here we are at the product deep dive, second session, and as I explained, we'll have the next session around governance next week, and then there's API maturity, use cases, success stories on the 4th week. Everything will be recorded, and I will publish it in the same Google Drive. You need to have access to Google Drive to be able to access it, but I saw quite a few of you have shared their Gmail addresses with me, and that's fine. So with further ado, I don't want to delay this much further. That's just introduction of the program, where we're at in the stage, and with that, I want to hand it over to Harish to go talk about the real stuff. Thanks, Harish.
Sure. Thanks, Kevin. And so maybe I will do quick introduction for me and Nigel. And then maybe I can take it through networking and all those stuff. So as you saw that there is a big agenda. So rather than I cover everything or Nigel cover everything, we are going to go back and forth, and so that you don't get bored of listening to one person. And then we will try to make it interesting, as interesting as networking can be, or other things can be. Please feel free to ask your questions. We would ideally like to answer everything at the last hour, because there is a long topic list. We would like to go through it so that you have a better background of when we are answering things. But before that, I'm Harish Kumar. I work as a customer engineer, or think of me as a solution architect for Apigee. Similar to other folks who joined last week and talked to you, I focus mainly on Apigee and integration product in Google Cloud. I have been with Google for about 4 years, and so far it's going good, and I'm liking it. As you can see, I love APIs, and I'm a little disappointed that Kevin and Nigel are not wearing their I love. Oh, you are? Cool. So disappointed with Kevin, not with Nigel. Come on, man. So we all love APIs. So we are really into APIs, and we like to talk day in day out about it. So feel free to ask anything you hear about today, or you heard last week, or maybe if you have any other questions which is not even related to Apigee, it's more about API management. We will be happy to talk about that also. So Nigel.
Thanks, Harish, and hi everyone. Nice to meet you. So Nigel Waters, exactly the same technical role as Harish, so specialist in the Apigee products and associated technologies around that. I've been with Apigee actually since a little bit prior to the acquisition of Apigee by Google. So with Google for about 7 years, I guess in total, with Apigee for about 8 years by now. And yeah, really excited to take you through some of these topics today.
Cool. So let's get started. So last week, our colleagues covered that you can provision Apigee through console. You must have, if you have not, you can go and go through a bunch of steps using UI or maybe command line or Terraform or whichever is your preferred way of provisioning Apigee. Now, when you provision Apigee, there will be a bunch of questions which you need to answer, or you need to take care regarding networking, which is not directly related to API management, but it is very important topic for any API which you are executing, whether are you running in a public network space, or is it running on a private IP space, or how do I connect to my backend systems? How do I let my external user or API consumer to connect to my API? So these questions we are trying to cover today. And so we have divided this into two major patterns, which we see, which is called as northbound and southbound. So to be honest, like when I started about 8 or 9 years ago in API space, I was a little confused. What is everybody talking about northbound, southbound? Why can't you say API consumers and we are exposing some services? So, but there is it's an industry standard to talk about it, so that you have a clear concept of similar to API contracts when you expose APIs. It is another linguistic contract of API developers, how we talk about it. So northbound is when you have an API and somebody is consuming it. So they are coming from their own network and calling your load balancer or maybe endpoint. So that's the northbound part of your API exposure. And then the southbound will be where your API platform or the API gateway or the API layer which you have built is going to your backend service, and that backend service can be a Kubernetes cluster, a GKE cluster, or it can be your microservices running somewhere, or maybe a monolithic Java application, or it can be anything like database or whatever. So that's the southbound part. So if you are not aware of northbound and southbound, so that is what northbound and southbound means. Now, whenever you have northbound traffic coming in, the first thing you have to think about how your consumer are going to connect to Apigee itself. So when you provision Apigee, so Apigee will provide you internal load balancer, which it exposes on an internal network which is running on a Google managed project. Let me get a marker so that I can draw some beautiful diagrams on this. Okay, here. So when you provision Apigee, so Apigee provisioning wizard or Apigee provisioning steps will get you an Apigee. So this Apigee instance is exposed with internal load balancer, and also created. It also creates a service attachment. So in Apigee itself, when you want to expose it to external consumers, there is an HTTP load balancer, which is Google Cloud Load Balancer you can create. Now, this Google Cloud Load Balancer, how it connects to your Apigee instance, there are two ways you can do it. Previously, about a year ago, there was only one way, where you have to create internal MIGs, which are basically an IP translation device which we create, which just takes a request from your external load balancer and sends it to Apigee. But from, I think, almost like a year ago, now we have released a PSE service, which is basically a private service connect. So what it does is, now you do not have to do any VPC peering between Apigee X, which is running in a Google Cloud project, and your load balancer, which is running inside your own GCP project. So as you are aware, when you're provisioning Apigee, the first step we ask you that, do you have a GCP project? And you say, yes, we have a GCP project. Now the next question will be, do you have a network available, a VPC network available, a subnet created where happening or your load balancer will be executed? So initially we had to create a VPC pairing, but that is not required anymore. So you can essentially consume the service attachment which is created by Apigee provisioning. And then to connect to that, your load balancer has to create a PSC nag. This PSC nag will essentially consume the service attachment which is available. And then from your external API consumers, they can call your external load balancer, and this is where you will basically provision your domain, your certificates, and everything. And at the top, you are saying Cloud Armor. So it's Cloud Armor will become our WAF layer, which can protect you from different kind of services. And we will cover Cloud Armor separately because it's an important service, and we will talk about why you need that. So this is a basic implementation of how you can expose your APIs which are running within Apigee, and then this networking pattern will become that simple pattern where you are exposing your APIs to external service using Google Cloud Load Balancer. So this is one of the pattern. Now, there will be a requirement where you want to connect to your Apigee X using an internal load balancer. So in the previous step, we had an external load balancer which you are using, and then exposing it using that external load balancer with the all domain and everything. But you might need an internal services which you are running within your own VPCs. For example, it can be a Kubernetes service, or it can be a compute service where you are running some kind of application which wants to consume your APIs which are in Apigee itself. Now, most of the time, you can go through your external load balancer and call that service which is running in Apigee. But what happens in that case is your Kubernetes or internal clients will have to go through internet and go to that external load balancer and then come in to your own network again. To reduce that network hop, what you can do, you can create an internal load balancer, and that internal load balancer can be accessed from your internal services which are running within your VPC itself, or if it's a VPC which is paired with your VPC which is consumed by Apigee. So now this internal load balancer, because there is a limitation that internal load balancers cannot connect directly to a service attachment, or they cannot create consume a service attachment, you will create a bridge VM. Similar to what it is it's just doing IP translation between this bridge VM, and then that bridge VM is going to attach itself to this endpoint attachment and then access service attachment. And I know I can't see everybody's face, but I'm throwing a lot of jargons of networking here. If you're confused at this time, do not worry. Just keep in mind that there are options of doing these things. When it is more important when you are going to implement something that you remember that there are patterns to implement it, and we will share the slides and everything. So you have a pattern available for you, and then you can take it up and implement it based on your use case. Now, another requirement or use case is where most of the time we will recommend to use Google Cloud Armor as a WAF layer, but not every customer or not every partner or not every application or organization uses Cloud Armor as a WAF layer. Sometimes you will have Akamai or your external load balancer like F5 or something which you're using. So in that scenario, how you can use your external WAF in front of Apigee is, so your external WAF will become your load balancing pattern, and all the requests from your API consumers will first land up into your third-party WAF layer. And from that third-party WAF, within Google Cloud, in your GCP network, GCP project, or in your VPC network, you will create an L4 external load balancer, which is basically just a pass-through. So all the certificate translation and SSL handshake, everything happening on your WAF or the external load balancer which you have. And then you just pass through that request to an external load balancer, layer 4 external load balancer. There is a difference between HTTPS and L4 XLB. So that will use internal VMs to again connect, similar to previously where we have internal load balancer. That is also doing this network translation and then connects to Apigee over your internal network. Yeah. Again, so at the bottom, one thing I want to cover is some places you will see this MTLS. So if you want to implement mutual TLS handshake happening between your client and your load balancer and everything. So all these patterns mention that where this MTLS can happen and where you need to go and set all these things. Cool. So another use case where you might have that, okay, I have my Apigee X APIs running, but now I want to connect all these APIs and consume these APIs from my serverless applications or services which I'm running. And when I talk about serverless within Google Cloud environment is Cloud Functions, Cloud Run, App Engines. All these are serverless services which Google Cloud provide. Now I want to consume my APIs which are within Apigee, and they might be exposing some service behind them. Now I want to consume those from my serverless infrastructure. To do that, in GCP, these serverless services, they provide a serverless connector, which essentially is similar to PSC, which is Private Service Connect again. So it uses similar kind of construct where the serverless connector makes it easier to connect to any other service in Google Cloud without even peering those networks. So you will see that your network and Apigee's Google project network is not peered here, but this serverless connector is making it easier for you to connect to the Apigee services which are running behind. So there is a bunch of commands or UI available where you can create the serverless connector, set up your IP ranges, you give your connection from your serverless connector to Apigee, and the services which are exposed within Apigee can be accessed there. Cool. Now that's all good. Now the next stage or the next requirement you might have that I'm not running everything in Google Cloud, or maybe not even some other cloud. I'm running everything on-premise, but I want to consume APIs which are running in Apigee's pay-as-you-go, which is a managed service in Google Cloud. Now I want to consume those. How do I do that? So there are different ways of accessing that also. So if your on-premise network has internet access, then you can directly call the external load balancer, which we created in the first pattern where your Apigee services are exposed. But you might have requirement that I do not want to, or we do not want to go over public internet network, and we want to create a private network space where my internal on-premise services should be able to call my Apigee instance or Apigee services which are, or APIs which are executed. Now to do that, there is one way of creating a cloud VPN interconnect. So what this does is it creates a networking space or a BGP session between your on-premise network and your VPC, which is in your Google Cloud project. This interconnect or cloud VPN makes it easier and gets everything on a private network space. Now, once you have that private network space connected, you can create an HTTP internal load balancer. Important is internal load balancer. It is an internal load balancer where your on-premise services are connecting to that internal service of the load balancer. And they're not going to an externally exposed load balancer. And then every network connection is happening on your private network space. And behind that, it's the same story. You have to have a network bridge, and that network bridge will connect to your Apigee instance. So this is one pattern of connecting your Apigee X services to your on-premise northbound traffic. Now, there might be that instead of having an ILB, I want to create an pass-through and TCP handshake, mutual network handshake of certificates I want to do. So in that case, you can have this kind of pattern where, again, those interconnect is getting them on private network space, and your internal load balancer is doing this TCP pass-through, and the whole same networks which you have set up already can be consumed. Now, southbound. So now you have exposing, you're creating services, but your APIs within Apigee, if they are not connecting to your backend services, they are not doing anything. So most of the time you're running your services behind the scene. You need Apigee to connect to your services, which or backend service which you are creating, maybe a database or a microservice or whatnot. Now, how does Apigee connect to that is Apigee can have this, like you can choose to get this Apigee's runtime to have a direct internet connection to your API services, or it can be a third-party service. For example, if you want Apigee to connect to your Salesforce or maybe to your Workday or whatever different kind of service you want to consume. In that case, you can have a CloudNet attached, and the CloudNet will give Apigee runtime access to that internet. And from that internet access, it can go to your backend services. So this is a very simple implementation of southbound traffic, which you can use. But most of the time, there are requirements that I do not want to give Apigee unbounded access to external network. I want to control where it connects to, and I want to put a firewall appliance within that. So what you will do, instead of Apigee runtime directly connecting using CloudNet, you will put a firewall appliance within that, and you create bunch of firewall rules that Apigee can only go to this service, that service, or you control the access from Apigee to your outbound services. Now, there is that I have internal services. For example, I created bunch of microservices in Google Cloud or on Compute Engine or maybe on GK somewhere. Now I want to connect my Apigee instance to those backend services. So you will, in most of the scenarios, you will use an HTTP load balancer, internal load balancer, and then Apigee can connect to that internal load balancer because there will be VPC peering network created, or it can also use service attachments within this and then connect to this internal load balancer and expose your backend services. So this is another pattern which you might see in your southbound traffic exposure, which you will have. This is another step where you're using a service mesh to create your microservices in Google Cloud. So your service mesh is running, and now you want to expose it. When you create a service mesh, it exposes an ingress gateway for you, which is based on Envoy. Now, instead of directly connecting Apigee to your ingress gateway, we recommend to use an L4 internal load balancer, just for the fact that if in future you add more services or more ingress gateways which are exposed, you do not have to go and change your configuration in Apigee. Apigee can continue to run using L4 internal load balancer and connect to your backend services. And with that, you can also dynamically change and add and remove services and access of Apigee to your backend microservices, or using your service mesh, which you have created. Next is that another pattern which you might see where you have a backend, and now when I was talking that you can use PSCs, this is a reverse scenario where Apigee is becoming the service consumer now. So you have a backend service, a compute engine, or maybe a GKE service or something. So you can expose a service attachment on your exposed service, and Apigee in this case is going to become the consumer and will do an endpoint attachment and consume your service which is exposed with the service attachment. So this is another scenario which also can be consumed from Apigee. So in Apigee's console and APIs, we have management APIs which we expose, where you can create endpoint attachment, give your service attachment information, and then Apigee runtime will be able to consume that attachment and pass through your traffic to your backend services. This is another scenario where your services are not in Google Cloud or in third-party cloud services. They are running within your on-premise, and your on-premise is protected. it's not directly exposed to internet. So in that scenario, you will have to create a cloud VPN interconnect to get your on-premises connected to your VPC network in Google Cloud. And then if Apigee is connected to your VPC, which is running in your Google Cloud project, it will be able to consume this cloud VPN interconnect, because these interconnects are regional. And then from there, if it's in the same region, it will be able to make this call and pass through your traffic to your services which are running on premise. Now, how you provision or create your services within your on-premise, it's up to you. As long as there is a load balancer or a network endpoint which is available to consume, and it is available on the same private network space, Apigee will be able to make that call. Now, in case Apigee is not directly VPC peered to your VPC network, which is in your Google Cloud project, this can be a scenario where you have not created a VPC peering and you are using service attachments to connect to Apigee and from Apigee to outside world. In that case, you will use an endpoint attachment and you will create an internal load balancer which exposes a service attachment. And then Apigee uses that service attachment to get into your network space. And from that network space, this internal load balancer is again connecting to your cloud interconnect and going to your backend service and consuming the service which is there on backend. So this is also another way of consuming your on-premise services. So either get Apigee into your as a VPC peering on your VPC network, or use service attachments as a PSC network to give it access using an internal load balancer. Cool. So that was a quick dump about networking. And if your brains have not blasted yet, I'll be really surprised, because mine was when the first time I saw all these things. So please feel free to ask questions. And now I will hand it over to Nigel to take you through more interesting stuff.
Thank you, Harish. Yes, we'll now take a little bit of diversion. So I guess the piece that Harish just covered there really fits into the category of the kind of foundation that will fit around Apigee. Obviously, it's pretty important that we can make sure that our requests can get into Apigee and those requests can be sent on to the back-end services that Apigee is proxying in front of. What we'll now look at is some of the capabilities in the platform, specifically when it comes to developing the API proxies that we use inside Apigee. So, of course, one of the core things we're doing in terms of the runtime layer of API management is we're using these proxies to act as a policy enforcement point to enable us to control the traffic, do aspects of mediation and orchestration, things like caching potentially, rate limiting, traffic control, or authentication, authorization, so on and so forth. So what we'll look at now is the kind of core concepts that sit around this inside Apigee, and some of the capabilities that we have. So we're going to look at things like shared flows as a reuse mechanism, flow hooks as a governance mechanism. We're going to look at routing rules as a means to enable us to route onto multiple different targets, all sorts of topics such as this. So let's start with the absolute basics. The kind of core thing that we work with when we're defining these API proxies is what we call these policies. And quite simply, policies determine what we want to happen in terms of the processing and control of our API requests and responses through the platform. Broadly speaking, these sort of fit into four main categories. So there's traffic management, so quotas, spike arrests for doing things like rate limiting and cache policies. There's security policies that sit essentially between policies that enable you to do payload level protections and policies that are going to be involved in authentication and authorization of the inbound requests. There are transformation policies. So these essentially are what enable us to do aspects of mediation. So we can transform the requests and responses that come through Apigee. A few other bits and pieces we can do inside there. And then kind of a bucket of stuff that we call the extension policies. So these include our ability to do things like use snippets of code inside Apigee, There are a few other things, for example, being able to publish onto a PubSub message, PubSub topic, being able to call a gRPC service, do some type of logging call to some type of logging system, and so on and so forth. But key point, policies are what we want to happen. And what we do is we take our policies and we compose these into our API proxy into flows. Now, flows define when we want things to happen. Now, overall, this picture looks a little complicated. So you can see we've got the request flow going through all these stages, the response flow coming back. Although it's not actually all that complicated in reality. In essence, this is a linear sequence of things that will happen as the requests and the responses flow through Apigee. First thing to notice with these flows is essentially we can divide them up on two different dimensions. So the top half of this diagram we're seeing is the request flow. So everything that happens between the request coming from the client into Apigee and that going to the back end. And the bottom half, we see the response flow. Next, we can see that we're splitting this by proxy endpoint and target endpoint. So on the left-hand side, we have the proxy endpoint. On the right-hand side, we have the target endpoint. The reason for that split, by the way, is to give you the opportunity to put different bits of logic in different places. Classically, you would generally try to put client-facing logic in the proxy endpoint side and target-facing logic on the target side. So things like rate limiting, authentication, authorization, that type of thing would generally sit on the proxy side. Things maybe like dynamically assigning the target, those types of things would more naturally fit on the target endpoint side. So with these two dimensions, what that gives us is 4 different, if you like, stages in terms of the lifetime of the request as it flows through Apigee. So first we have the proxy request. Then we have the target request. Then the request gets to our back end. When the response comes from the back end, that then goes through the target response flow, and finally the proxy response flow, and then ultimately that request is returned to the calling client. So that's 4 stages. Then within each of those stages, we then have pre-flows, conditional flows, and post-flows. So these give us opportunities to decide how we want our policies to be implemented, in fact, whether indeed we want them to be implemented for given any particular request. So at each of these 4 stages, whatever we put in the pre-flow happens first and always happens. Whatever we put in the post-flow happens last and always happens. And we can optionally choose to define a set of conditional flows. And our conditional flows are evaluated. The first one that matches to true is executed, and we only ever execute one conditional flow at any of these 4 stages. So what this actually then gives us is kind of 12 different places where we can put our policies in order to form the overall logic of the processing we want to happen onto the request coming through Apigee. Very typically for our conditional flows, what we'll do is we'll look to mirror the resources that are being offered by the backend API. So maybe we've got certain resource URLs, certain HTTP verbs, and quite often we'll have conditional flows that match to those. So a get request to /accounts, for example, could be a condition, and we could have a separate condition that might be a post request to /accounts, and so on and so forth. In fact, if you use an OpenAPI specification to create an API proxy inside Apigee, what we'll do is we'll pre-create all of those conditional flows for you based upon the resources defined in that OpenAPI specification. So yeah, quite a lot of sort of seeming complexity there, but I guess it all really does simplify down, particularly when you notice that this is really just a linear progression of these stages. One thing I'll also mention is that anytime we append or apply a policy into one of these flows, we have the opportunity to apply a policy condition that essentially determines whether or not that policy is executed or not. So you've even got a finer level of control in terms of on a per policy basis, we're able to make an intelligent decision about whether that should be enforced given the context of the particular request or response. So that's our kind of foundational building blocks of how we go about building our API proxies. So next, let's have a little look at our target endpoints, and then we'll see how these relate in terms of routing rules inside Apigee. And I seem to have a bit of a delay changing slides, but it is fine. So a target endpoint, generally when we say target endpoint, we're actually referring to those those two target stages, the target request and the target response flows that we have inside Apigee. Generally inside here, what we're going to be doing is any type of logic that is helping us determine that backend service. So if we're doing things like dynamic URL rewriting, so this is a capability of Apigee where you can change the target URL that's going to be hit. Also inside here, we're specifying our actual target server connections. So we're specifying things like what that URL is, any TLS style parameters, if this is going to be a mutual TLS connection. We're specifying things like the key stores and trust stores are going to be used to hold those certificates. In terms of the response, the kinds of things you're going to be doing in this target response flow is validating the status codes that we've got from the backends and deciding what we want to do with those. Now, one thing to note is, we're getting it again, is that sometimes inside our API proxies, we can actually define multiple target endpoints. What this means is we can actually have essentially an API proxy with our proxy endpoints and all the client-facing logic defined, and then we can actually link that to multiple target endpoints to enable us to send those requests to different places and potentially have different logic that's applied on that target side of the proxy flow. The way we handle that then is using something called routing rules. And routing rules essentially sit between the proxy request and the target request and enable you to specify a defined set of rules that indicate how we should determine which of our target endpoints any given request is going to get routed onto. In terms of these routing rules, they're evaluated in order. So the order which you specify them, which kind of go through top to bottom. The first rule that matches is the one that will be used, and that will essentially cause that request to be sent to that chosen target endpoint. In terms of when you're configuring it, you're doing this through the XML configuration for our endpoint itself. One thing we do recommend is you should always have a default route rule. So default route rule is essentially one that has no condition applied to it, and generally we would recommend that is the last rule that you have. Of course, what that is giving you is a catch-all type scenario, so that should there be the case that none of our conditions match, then at least we have an endpoint for that request to route onto. Moving on, we'll now talk a little bit about shared flows and their usage and flow hooks. So shared flows are a capability inside Apigee that enable you to bring together a bunch of policies with their configuration and essentially create this reusable fragment of policy logic. They are deployed to your environments, and they cannot be invoked directly, but they can only be invoked either as part of a flow callout call from a proxy that's deployed in the same environment where our shared flow lives, or indeed they can be invoked in the context of being bound as a flow hook, which is something that we'll look at in a moment. So shared flows, for those of you with a kind of background in programming, this is the equivalent to a function or a method. This is some type of logic that we built once and we're going to want to use multiple times. In terms of the flow callout policy, this is how we go ahead and actually embed a call to our shared flow. inside one of our API proxies. It's pretty simple. I mean, the only thing you actually need to specify with this is the name of the shared flow that we are calling. I did mention the fact that policies can be conditionally evaluated to decide if they should be executed. That can be a technique that you can use in conjunction with shared flows to enable our shared flows to be a little more generic, so we can have shared flows that can cater for multiple scenarios. And generally, you want to try to minimize the number of shared flows that you have. So, typically, if you can get that under around about 10 shared flows or so, that probably means you've got about the right level of logic in terms of what you're doing inside your shared flows. And common things we do with shared flows would be things like logging mechanisms, maybe security mechanisms, maybe if there's some type of security credential orchestration that's needed, maybe to connect to a backend system. I've got to retrieve an access token from somewhere. Those types of logics are the types of things we would expect you to be putting into your shared flows. So shared flows on their own are a reuse mechanism. So they prevent duplication, they speed up your proxy development time, but they can be used in conjunction with this capability called flow hooks to provide a governance mechanism. So flow hooks are defined at the environment level inside Apigee. There are 4 of them: the pre-proxy flow hook, the pre-target flow hook, the post-target flow hook, and the post-proxy flow hook. And these represent the first thing that happens inside Apigee after a request hits Apigee, the last thing that happens before that request is sent to the back end, the first thing that happens when that response is received from the back end, and the last thing that happens before that response is transmitted back to the client. Within the flow hook configuration, you specify a shared flow. And once you do that, then for every single API proxy that you have deployed into that environment, that shared flow will be executed at the relevant point in terms of the overall proxy flow. So as I mentioned, this essentially then becomes a governance mechanism, because you're able to, of course, mandate and define these. So for example, we define our security and our logging policies in this way, and now it is no longer possible for anyone to deploy an API proxy to Apigee that doesn't have these controls that we've defined in place. So quite a powerful capability. Yeah, in terms of the UI, so you'll just find it under the admin section and then environments in the user interface to define them. And yeah, I think we've kind of covered this, but yeah, there's a common series of conditional policies that we want to use. Okay, next we'll move on again, and we'll talk a little bit about some of the mediation capabilities we have inside Apigee and kind of how we want to approach this. Mediation is not always going to be a requirement. In an ideal world, you would have back-end APIs that we're proxying through Apigee that actually mirror the types of APIs that we'd want to put into the hands of our consumers. For sure, that is not always the case, though. There are circumstances where perhaps we as the API team configuring these APIs to make them available to our consumers, do not control those back-end services, and maybe there's reasons why they can't be changed. And yet, we want to present these APIs in a maybe a more easy to consume, easy to understand manner to our consumers. So, one capability that Apigee does give you to solve this challenge is it enables you to do mediation. And mediation, quite simply, is the process of us taking an inbound request in one format, transforming it to another format to make the backend call, receiving that response, and then doing a transformation again to return the payload in the format that we want. One kind of aspect or subset to this is one thing you can do through Apigee is do what's called a SOAP to REST to SOAP conversion. And this is something typically would be done as part of some type of legacy modernization exercise, where potentially we've got some SOAP-based services, and what we actually want to do is offer those as a REST-based interface to new clients. and essentially we'll just use Apigee as a mediation layer to enable that to happen. There are two main policies inside Apigee that you'll use for these types of mediation purposes. Those are extract variables and assign message. Extract variables enables you to pull details out from any part of the request or response and actually store those values as variables that can then be referenced later. With this, we can access any aspect. So we can access any of the parts of the path and the path parameters, our query parameters, header parameters, form parameters, the payload. And if we are accessing the payload, we can use JSON path or XML path to essentially pull out specific elements from the payloads, whether they be in JSON or XML format. That's that. Oh, yeah, one note here. If we are looking to use extract variables to extract elements from the payload, you must make sure that the content type header is of the corresponding type. So if a request is coming in with an XML payload, we need to make sure that has got the content type header to XML in order for Apigee to understand properly that that is an XML payload and be able to appropriately apply the XPath queries onto it. Assign message is a bit of a kind of powerful policy we have inside Apigee. Kind of got a fairly innocuous name, I guess. But with assign message, you're able to alter any aspects of the inbound request or response. So again, any header parameter, query parameter, form parameter, the payload, also the request verb, the status code, all of these are available to us. And you can interact with this, you can remove elements, you can add new elements, you can set these to be whatever that you want them to be. One common thing you should be looking to do with this is if we are doing some type of security credential mediation through Apigee. So what that generally means is we are trusting Apigee to authenticate the clients, and we are using some other authentication mechanism to the backend system. Then a common thing you'll want to do is strip those authorization headers from that request before we send it to the backend. The reason for that is just fairly obvious. Things like security credentials, you shouldn't allow them to propagate further than the context of where they're actually needed. So if those credentials are not going to be validated by the backend system, then just simply remove them on the way through Apigee. And you can see in this kind of sample here, that's a basic example of how you would, for example, remove the authorization header from an inbound request. One thing we can do as well is we can make use of something called message templates inside Apigee, and this is quite a powerful capability. So in certain policy configurations, you can use these. The way you use them is you put variable names in curly brackets. So these will refer to any variables maybe we captured from our extract variables policy, or indeed we set from our assign message policy. Assign message can also create variables, and then within this you can also run some functions as well. So you see here there's some built-in functions like encode base 64. Of course, it's going to do by base 64 encoding. You can do things like time formatting. You can also run things like JSON path as well. So quite a sort of powerful capability to enable you to modify and work with what you've got available to generate the requests and responses as you need. One other aspect to mediation is orchestration. So orchestration really just means the ability for us to hit multiple backend services within a single API request response. The way you will do that inside Apigee most typically is using a service callout policy. So this enables you to hit multiple backend systems. Kind of two common patterns we see here is the mashup, or to give its more formal name, the policy composition. which is where simply we hit multiple backend services, we grab all that data, and again, using extract variables and assign message policy, we will mash that together into a single payload to respond to the consumer. The other common one is what we call the enrichment pattern. So in this pattern, I need to hit my backend service A, but in order to hit my backend service A, I must first retrieve a value from backend service B that I'm going to use as part of that call to service A. So in this flow, we hit one service to receive some data that is required for it to hit that other service. There's some sort of common examples of this using things like the Google geocoding API, where maybe we've got a postcode, and what we actually need is latitude and longitude coordinates. So you'll first make that call out to do the translation, and then you'll use that translated value to actually hit your actual backend system. Actually, just one little note on orchestration. Orchestration that you're doing in the API layer should be in general lightweight. So just always bear in mind that RESTful APIs are asynchronous, and are designed to be fast. So don't do things that will result in slow responses. And of course, you've got to come up with other means and mechanisms to deal with any async style requirements, which can quite often come up in terms of orchestration-based requirements. So our service call-out policy, quite simply, enables us to specify the actual request that we want to make to this backend service. So we specify the headers, the query parameters, the payload, so on and so forth. Of course, the actual URL of that backend service that we're going to hit. That, by the way, is not any different than the sort of the configuration, if you like, that you have for the the actual request and response that's flowing through Apigee. One aspect to this that we can do as well is we've got the concept of proxy chaining. So this enables you to chain together different Apigee API proxies. So this can be a useful technique where maybe we've got proxies with certain bits of logic we want to access from lots of different places. Now, when we do this, if you are doing this on a kind of internal configuration with the local target connection, what's actually going to happen is that request is going to stay fully inside Apigee, so it's not ever going to transition outwards. So that's of course going to help in terms of performance in regards to this. Change sort of tack again, and now we'll talk about custom code policies inside Apigee. So we give you 3 different options for you to go ahead and add custom code to your API proxies. You can do this with JavaScript, you do this with Java, and you can do this with Python. And the reason you would do this is sometimes a few lines of code just give you a lot more flexibility than you have with, of course, the configuration-based mechanism that we give you with all of the XML style policies. The one most likely you will be using, or most commonly would be used, is the JavaScript policy. So you can do a lot of stuff with this. A pretty common use case is if we've got to modify a JSON payload, then of course JavaScript becomes a really good option for this. One other thing you could do with this that's definitely worth knowing is you can use the JavaScript policy to actually make a HTTP client call out. Now, the reason you would do that is this will enable you to do things in parallel. So by default, in that mashup example I talked about using the service callouts, each of those backend services would be hit in turn. Once the response will come back, we'd hit the next one, the response will come back. Using the JavaScript policy, what you can actually do is you can fire off multiple HTTP client requests in parallel, and essentially then synchronizes all of those come back in to enable that response to be processed back to the client. There's an object model. It's documented on a documentation site. Kind of at the heart of it is the context object, which essentially gives you access to the Apigee variables and the various information in regards to the flow and the requests and responses going through Apigee. There is a crypto object we provide that's there to enable you to do various cryptographic operations. Those we'll come to in a second. Probably not the best choice to use JavaScript for that. And there's also something called context.session, which enables you to pass variables about between different policies. Quite important often when we're doing these programming aspects, so we've got some extra debugging capability. So for this, with the JavaScript, you can just simply use the print function, and that basically prints to the console, so you'll see these messages appear in your trace tool inside Apigee. Next, we've got the Java callout policy. So for this, you're going to have to essentially write a Java class, package that in a jar file, and make that available to Apigee. There's some interfaces we provide that you need to implement in order to build your Java class. So you can actually see here it's implementing this execution interface. And that, of course, then gives the various methods that provides the hooks from the Apigee back into your Java code. Do be aware that for security reasons, there's a whole bunch of stuff we're not going to let you do in terms of the Java code. So, anything that's going to be accessing network information, CPU information, process info, file system access, of course, that's just not going to be allowed. Of course, for fairly obvious security reasons. And then finally, we have the Python policy. It can kind of do what the JavaScript one does, but honestly, general recommendation is don't use it. Actually, it runs under an interpreter called Jython. For that reason, it's not particularly performant. It's really there just for people who really, really, really love Python. But we wouldn't recommend using it unless you feel like you absolutely have to. When it comes to deciding which of these to use, so the first thing you should decide is, do I need to use one at all? Where possible and where it's not going to be overly complex, always use the out-of-the-box message policies. They're fully optimized. There's a big breadth of those, as we saw up front in this section. That's really what you should be turning to in order to use. Use JavaScript when generally what we're doing is basic manipulation style things. Generally, you would consider this as a default choice. Use Java for high performance, and I would include in that, if you need to do any heavy cryptographic operations, then that will be significantly more performant using Java. And don't use Python. And hosted targets is an old thing that shouldn't be on this slide, so ignore that, please. Okay, and then finally, to round out this section, let's talk a little bit about fault handling inside Apigee. So Apigee has a fault handling mechanism. In essence, when a fault happens, that aborts the normal kind of flow, and actually it jumps to a fault rules processing that we have inside Apigee. Actually, one thing you'll note when you are working with the Apigee policies is all of them have a flag that enables you to determine whether or not you're actually going to jump to the fault flow if there's an error from that policy. And a fairly common pattern you might do is configure that to false, and then you have something subsequent to your Apigee policy that then detects some conditions and potentially uses a raise fault policy to then trigger into the fault handling flow. If you haven't specified fault rules, then we are going to send error responses back anyway, but those are going to be the default error responses, and you probably don't want to be sending back the default Apigee error responses to your clients under normal circumstances. Fault rules are defined hierarchically. Only the first matching fault rule is or condition that matches is chosen. After that's chosen, you then define a bunch of steps. Typically, these are going to include an assigned message policy that's going to craft the response payload we want to send back, and that's and then that's going to process the logic to send that response. There's one funny little gotcha here, just to be aware of, that on the proxy endpoint, fault rule conditions are evaluated in reverse order. So just be slightly aware of that when you're defining this. You should have a default fault rule defined. This default fault rule essentially is there to give you this kind of catch-all, and it gives you a generic way to define something that we want to happen. If in this circumstances. Now, there's two ways you can configure it. You can configure it with always enforce equals true, which means this rule always runs. So we're going to do our other fault rules steps, and then we're going to run this. Or you can have it as false, which means this now becomes more like a kind of catch-all condition, and we're just going to execute that logic should that end. So faults are initiated by any policy failure with continual error equals false. That's the flag I was talking about. They're also initiated based upon the response from the backend system. And do notice there is this success codes configuration you can specify to determine whether we want to treat or what, in terms of responses from the backend, we want to treat as a fault. And you can explicitly trigger them by using a raise fault policy that essentially just gives you a way to sort of kick into fault handling. Be aware as well, the one thing you probably want to do is include this 404 not found pattern, which essentially means that you're kind of using this for any request that comes in that doesn't conform to one of your conditional rules. Which, if you create that from the OpenAPI spec that you're using, of course, will match the resources available in your backend API. By doing this, essentially what this means is anyone trying to sort of get around the side and gain access to your backend systems is going to get prevented, and they're just simply going to get a 404 response if they're using anything that doesn't form part of your actual API request. So, again, a bit like Harish's section up front, a lot of information we went through there. What we've tried to give you as a flavor of all of these different capabilities that you have. We've given it all the highest possible level treatment there, but hopefully that's given you an understanding of the art of the possible, and that will help point you in the directions of the kind of things and aspects you should be looking at in terms of your proxy development through Apigee.
Okay, so next is security. So whenever you are creating APIs within your organization or you want to expose, so security should be the first and topmost thing you should be worried about. And it's no different in Apigee's case also. So when you're creating APIs, there are a lot of different things you need to think about. How your API consumer are going to consume it, what are the different authentication, authorization mechanism you're going to use, how your network security will work, how your connectivity to backend systems will work, what kind of role-based access are you going to use for the developers who are building your APIs, if are you going through some threat, internal threat or external threat. So Apigee provides a lot of end-to-end capabilities to secure each and every aspect of your APIs. So it's not only just Apigee, because we are part of Google Cloud. So we use a lot of Google Cloud services as well to secure the whole ecosystem of your APIs which you are building. And we will cover some of that today. And I think let's first talk about this. So the first thing you will see, or when you expose an API, you will have to think about the DDoS protection or bot protection, which you need to think about. How Apigee implements that? We use our own WAF layer protection, which is provided by CloudArmor. And CloudArmor works in conjunction with our load balancer. So in the networking space, when I was talking about, you might have noticed that the theme is that most of the time, whenever you want to expose your APIs, you will use Google Load Balancer, and that Google Load Balancer, because it's a global service and it works in parallel with CloudArmor. So whenever you're exposing your service, CloudArmor can sit in front and give you security or indeed denial of service protection or bot detection at the peripheral of your Apigee or API's exposure. which is also important in case of Apigee, because um, this is a pay-as-you-go session for Apigee. We have a subscription model also, but because we are talking about pay-as-you-go, it is the more you consume, the more APIs are executed or processed by Apigee, the more consumption you will have, the more bigger bill you will get, essentially. Now, there might be a scenario where you do not want to send all these API calls or this DDoS attacks or bot attacks which are coming into your API. So that protection can be provided by Cloud Armor. Because Cloud Armor and Google Load Balancer are working outside of Apigee's scope. So if a request doesn't end up in Apigee, it is not charged. It's not calculated for your APIs or Apigee consumption. So, for example, you're getting a big DDoS attack on your APIs, and if you do not have a Cloud Armor protection enabled on your load balancer, all these requests will be coming into Apigee, and Apigee will be processing it. And even if you block it at Apigee level and you have some IP protection built in using our own internal policies, but still Apigee is processing it. So you will be charged for that and you will have to pay consumption fees on that. But if you're blocking it outside at Cloud Armor, so Cloud Armor is based on Cloud Armor can protect you for L3 to L7 volumetric attacks. So what it does, it will learn over the period of time for your different network or the request patterns, and it will send that information to the machine learning model which is running within Cloud Armor, and then it can detect if it's a valid request coming in, or if it's an attack coming in, or if some mischievous activity is going on, and then it can block those, and it can suggest that maybe enable this kind of rule on your Cloud Armor, and then it will stop all those requests coming into your Apigee's implementation itself. Now, there are different kind of threats and different kind of products within Google Cloud itself which you can use. For example, depending on whether you are thinking about threat protection, access control, self-service, or governance, or data security. So Apigee itself provides a lot of out-of-the-box policies. So when Nigel was talking about that, we have policy for JSON threat protection, XML threat protection, where we can detect if the JSON is a valid JSON before even you process it and send it to your backend service, or you do some implementation on that, or if it's a valid XML or not. And we provide a lot of authentication, authorization out of the box policies to control the access to your APIs. And when I say access to your APIs, think about the API consumer access, not the API developer access. I will talk about that API developer. How do you do that? Then also, we provide out-of-the-box policies to integrate with third-party identity provider. For example, you might be using Okta or Ping or whatever identity provider you have. So Apigee can work in that scenario also and becomes a service provider and use external identity provider, which you can implement API consumer authentication authorization with that. And then during networking session, we talked about that you can use TLS connections. By default, all the services exposed will use HTTPS, and then you can also extend it and enhance it by using a mutual TLS for your northbound traffic and your southbound traffic, both of them. So that is at Apigee level, which is happening. So there is something called as advanced API security. Basically, what it is it's a bot detection and protection which is running in the context of your APIs. So similar to what Cloud Armor is doing based on your volumetric traffic which is coming in, there is a machine learning model implementation or different kind of rule implementation which is done in Apigee, which can protect you from your from two kind of threats. One is configurational mishaps. For example, you might have created an API, but you forgot to put JSON threat protection, JSON threat protection, and XML threat protection, or maybe you didn't put any OAuth validation or API key validation. So the advanced API security can do recommendation where it can scan through all your APIs. Because think about like in when you have a lot of APIs you build over the period of time, you will have, if not tens or twenties or hundreds of hopefully thousands of APIs which you are exposing. So now it becomes very difficult for somebody to manually go, and your security teams to manually go and scan and read through each and every API what is happening. So this configurational threat to your APIs can be taken care by this advanced API security, and it can do recommendation that maybe try to use this and maybe do that on your API to make it secure. That is the configurational part. And then it can also do DDoS protection and bot detection in the context of your API. What I mean by context of your API is your layer 7 protection based on how your APIs are defined and how different kind of API execution is happening based on the identities of API consumer. It can see that most of the time this API consumer is calling your API with this pattern, but suddenly the pattern has changed, or there is some kind of anomaly happening. So those kind of threats can also be protected by advanced API security. Again, not available right now in Apigee, but the whole point of using Apigee right now is to so that you can have your APIs exposed and made your program bigger. So over the period of time, you might move to subscription model, and then it will be available. But so that is what advanced API security is doing. So then there is reCAPTCHA. So again, it's more like a bot detection on client side. So you can use reCAPTCHA's different scoring mechanism which it use and feed that information in Apigee and then control different kind of bot attacks which might be happening on your API itself. So all these product can work together and provide web API protection on your APIs itself. So a little bit about Cloud Armor. It has different kind of functionalities, and let's look at this basically. So it does layer 3 to layer 4 DDoS defense protection. Okay. I think this needs to be updated. It's not in preview. All these three are already in GA also. We'll update it later on. So basically, you can write different kind of custom rules where you have access to different request information. You have header information, the metadata information associated with your request coming in. You can write bunch of different rules. There are out-of-the-box OSAP WAF rules. What basically this is, for example, you want to implement SQL injection protection on your APIs. You can use Cloud Armor's SQL OSAP rule, which is out of the box available. You enable it, and Cloud Armor will start protecting. Now, most of the time, when I talk about these OSAP rules and that you can use Cloud Armor for that, rate limiting for Cloud Armor also can do. The question which is asked to me is, why then I use Apigee to implement OSAP rules or rate limiting, and then I use Cloud Armor also? Why there is a overlap of functionality? So keep in mind that security at every level, every layer is important. And what Apigee is providing you much more than this basic functionalities what are available in Cloud Armor. So Cloud Armor doesn't have all the information regarding your API consumers. For example, there is an API consumer who can call your API 10 times, somebody else can call it 200 times. So that Cloud Armor will not have that information because it is not maintaining the API consumer information or the assets regarding that. So Cloud Armor is doing based on network volumetric information and the different metadata information which is available in your request itself. And Apigee goes little beyond than that, and it gives you more advanced features and functionality which you can use to implement your different business use cases. Nigel, you want to take this?
Yeah, cool. Thank you, Harish. So yeah, just a couple more topics to kind of round out on. So we'll talk analytics, and then we'll come on to the publishing aspects inside Apigee. Analytics capability baked into the Apigee platform. So as soon as we start running traffic through Apigee, we are capturing this analytics data. do be aware that by default, what we're capturing is not generally what's considered to be sensitive data. So unless you tell us otherwise, Apigee is not going to capture things like aspects of the payload and so on and so forth. And the reason for that is this analytics data. It's the only data that Apigee is storing at rest in terms of your API traffic. With the analytics capability, you get a bunch of out-of-the-box dashboards and reports that you can use. These give you different views in terms of the nuts and bolts of your API traffic, so call volumes, latencies, cache hit ratios, so on and so forth. You get a bunch of developer-based analytics, so who are your developers, who are your top developers, what are those apps and experiences that they're building with your APIs. And we've also got some end-user analytics, so that's using things like client IP addresses and user agents to give you details in terms of the geographic location of your clients, and also things like the devices that they're using to access your APIs. One of our policies that we have is called the data capture policy. And what that enables you to do is to put any data you like into the analytics data store. And if you do that, you can then go ahead and you can generate custom reports inside Apigee that actually use those custom metrics that you're capturing. So maybe you've got some type of customer ID or product ID or some type of identifier that's super useful for you in terms of the analytics. Then you can ask Apigee to capture that, and that then becomes available to you. You can consume the analytics just through the Apigee console. So directly inside there, you can view these reports. You can also query this analytics data. So there's one of the management APIs of Apigee enables you to essentially query this data. That can be useful for enabling it to be ingested into any other system you have. So maybe you've got a centralized BI style system that you want this data to get into. There is also a export capability. So this is designed to be a snapshot style mechanism. So you're limited to running this once a day. And the typical use case we envisage is you're on a daily basis, essentially dump out the entire contents of the Apigee analytics. That data can be exported directly into BigQuery. So of course, which would then enable you to do any type of querying onto it, or you can put it into a GCS storage bucket, which of course would then enable you to consume that data from any other system that you have. In terms of the custom reports, it gives you a customizable mechanism. Essentially, you can go in, define the metrics and dimensions, including any custom analytics fields that you've specified that you want to have included in those reports. We've got the ability for you to do drill downs and essentially cascades, so you can essentially drill into deeper layers of the actual analytics data. We also have the ability for you to generate larger analytics reports using an async processing mechanism. Essentially what that looks like is you create a report job that's then run asynchronously, and you're able to then access that data subsequently. So that, by the way, by default, you can't run analytics reports in a synchronous fashion beyond time window of, I think it's 2 weeks. If you want to run longer ones, then you're going to use this async mechanism to enable you to do that. There is a retention period associated with your analytics, so yeah, just do be aware. If you want to persist this data for the long term, then what you're going to want to do is extract that into some type of long-term storage mechanism to keep that data for longer periods of time. Thanks for bearing with us. We've obviously covered quite a lot today. We'll come on to the topic of publishing inside Apigee. So we talked an awful lot about the kind of runtime capabilities. So we started off with just the networking requirements to get the traffic essentially through Apigee. We've then looked at all the things we can do in terms of the proxy configurations and how you actually configure that together. Publishing is now the process of how you take those API proxies, those endpoints you're creating inside Apigee, and get those into the hands of your consumers. So the core concepts we use to handle this are API products, developer apps, and developers. So API products are bundles of your API proxies and the specific endpoints inside your API proxies that you want to make available. Developer apps is a registration of an intent to use an API product from a developer, and developers just simply represent the identities of the consuming developers of your APIs. And typically, most often, those developers are external API users who are interacting with your APIs. And by external, really, we just mean these aren't people who administer the Apigee platform. These are people who sit outside of that team and are essentially acting in that API consumer role. So API productization essentially gives you this abstraction layer. And really, the goal of API productization is to do two things. Firstly, you're looking to make your APIs easy to consume. So the way we kind of generally talk about this is with a Lego style analogy. So if you think of your API endpoints as Lego bricks, an API product is like a boxed set. So if I walk into a Lego store and I want to build something, and what I do is I have to go to a big bucket of bricks and find all the pieces that I need. That's a really horrible consumer experience, and of course it's difficult for me. I probably won't find all the bits that I need. It's going to slow me down. It's going to make me an unhappy consumer. In contrast, if I go into the Lego store and I want to build something, and firstly I see that there's a bunch of shelves organized to sort of point me in the direction I want to go, and then so I find the shelf that I want, and inside there I see all these boxes with pictures of things I could build, and I can see the thing I want, and it's got a nice picture and a nice description, and I pick up that box, and inside all of the pieces that I need are in there. That's a really nice consumer experience, and that's going to enable me to go away and build that thing really quickly and efficiently. And of course, from an API management context, making sure that our APIs are easy to consume is pretty much the goal that we're looking for. The value of our APIs can only, of course, be measured in terms of their consumption. So our API products enable us to bring together these endpoints into this kind of box that makes sense to our consumers. We can add taxonomies and categorization to it. So we can add custom attributes to our API products that can then be used in a presentation of those products to our consumers to organize them and make it easy for our consumers to appropriately find our API products. And attached to them, we can also add quotas. So we can define different levels of access. So one common approach is you might have gold, silver, and bronze level products that represent different levels of access to our APIs. Different volumes of requests can be represented by those different products. So products become a consumable unit. So what do we do with those products? Well, what we do is we publish them to our developer portal. Apigee provides three basic means for creating a developer portal. There's what we call the integrated portal, which is just built into Apigee. It's kind of hosted by Google. It is a fairly basic capability, but provides you what we would call an opinionated developer portal. Opinionated in that it works in the way we've decided a portal should work. You can't really customize it, particularly beyond some basic branding. But it is for some of our customers, it's all that they need. So that's an option for them. The second option we provide is based on Drupal. Drupal is an open source content management system, and we provide some Drupal modules that give you a framework API developer portal, along with all the wiring needed for that portal to communicate to Apigee. One option you have for your Drupal developer portal is we actually have an offering on the Google Cloud Marketplace, which is an Apigee Drupal developer portal, and that will essentially give you a hosted Drupal developer portal for you to utilize. Alternatively, you could host your own on your own infrastructure or some compute engine instances, Or indeed, there are other third-party Drupal hosting providers, so there's companies like Pantheon and Acquia, and niche players like Pronovix, who specifically host API developer portals. A publishing process is slightly different depending on whether you're using the integrated portal or a Drupal portal. With the integrated portal, essentially you just publish an API product to the portal, and associated with that is the API documentation, represented by an open API specification, and that gets published. With the Drupal portal, essentially you go through the Drupal console or use one of the automation mechanisms you have with Drupal, and essentially you're publishing that as content pages into the Drupal portal. With the Drupal option as well, by the way, you get the opportunity to choose what renderer you want to use for your API documentation. So we provide one, but you could equally, there's one provided by Swagger, the other third-party ones out there. You can pick and choose exactly which renderer you want to use for your API documentation. And so our third option is you can use the management API of Apigee to go ahead and build your own developer portal. The reason you would do that would typically be because maybe you have some type of portal technology that you really like. Maybe you have a ton of React.js developers, and this is a technology you've chosen to standardize on, and you would like your developer portal to be built in that technology. Or perhaps you have an existing portal user interface of some kind, and what you're looking to do is, rather than provide a standalone Apigee portal, what you're looking to do is just embed some aspects of the API consumer management inside that other portal. For those purposes, the management API of Apigee can be used to essentially build that integration from your custom built capability. But whichever of those options we use, this is a place that our API products get published to in order for our consumers to discover them and sign up and gain access. You can control the visibility of those API products. So one option you do have is to have multiple developer portals for different groups of consumers, to which you publish different subsets of your API products. Another option is you can essentially use what is a role-based access control mechanism. So in the integrated portal, this is based on something called teams and audiences. It's more of a true RBAC capability in the Drupal developer portal. And that enables you to restrict visibility and access to your API products. Common thing you might do here is maybe you've got a set of internal consumers and you want to provide them a view of your entire API catalog, and maybe you have a set of external API consumers and you have a subset of your catalog that's is only appropriate for external consumption. But you publish these API products to your developer portal, and then you make these necessary configurations to control the visibility. From there, the process is that the consuming developers are going to register their developer apps against your API products. When you configure the API products, you're able to define whether you want approval to be automatic or require a manual approval. And based upon that, your developers will either be able to automatically get their apps approved. Within the app, they will then gain access to API keys and secrets that enable them to securely call your APIs. And of course, if it's set for manual approval, then your configured API product owners will get notifications, and they then need to go into actually decide whether or not they want to approve this specific access request to your APIs. If we're using the Drupal developer portal, a fairly common thing to do is build some type of workflow into this app registration and approval process. And that can be doing basic things like including KYC style checks to verify the developer identities. Might even be doing slightly more sophisticated things like you may have a process for access to a production API that will use Apigee Analytics to ensure that the consuming developer has been running sufficient test calls against your sandbox API products before you even allow them to be considered for production access. You can really make that as simple or as complicated as you like. One little note of caution there. generally you want to make it as easy as possible for people to discover and gain access to your APIs. So do not put up unnecessary barriers to adoption.
So when Nigel was talking about analytics, so Google Cloud has Looker Studio, which is available, and as Nigel said, that all the API analytics we are storing in BigQuery, and this Looker Studio works very well with BigQuery. So what you can do is you can build your own dashboards in Looker Studio. So if you do not like the dashboards or graphs and tools and whatever we have in Apigee's console, so you can build your own. So right now I'm just showing you a sample of what is happening is I have a Apigee proxy running, Apigee organization running, and it is just getting all the data from the BigQuery table which Apigee is creating. You can also do another thing, that you get all this data into your own data sets of BigQuery and then merge it with some other information which you want to, and then build much more better, beautiful looking dashboards in Looker Studio, because Looker Studio is the BI tool which Google Cloud has. So Apigee is not a BI tool. Please keep in mind, a lot of time I get a question that the graphs and everything is not very customizable in Apigee's console. So it's not a BI tool. We are providing those analytics as a feature, but you can always take this information out and use any external BI tool to build your own dashboards.
Let's close the call. Thank you for joining.
Sure. Thank you so much.
See you all hopefully in a following session.
Thank you. Bye-bye.
Bye-bye.